in other words, one might even say if there were no consciousness, there would be no universe.
That is really true, but that's a hard one for everybody to accept, because everything seems so solid and out there. I mean, the chair is solid, my body is reasonably solid, I don't want to get hit by cars, blah, blah, blah. There's so much stuff telling you that there's a real out there, that to think that the mind has anything to do with its being there seems unthinkable, seems impossible. But yet, that when we come down to the fundamentals upon which the gross material world is built, mind is instrumental in its appearance.
Yeah. Now let's focus a little on time for a moment. The first thing that comes to my mind when I think about time is Einstein's great thought experiment. What would it be like to be riding on a photon at the speed of light?
Yes, that was Einstein's big question was, if I'm moving at the speed of light and I held up a mirror, would I see my face? And at first your mind does a double take on that. Well, why wouldn't he see his face? Oh, but wait a minute. If he's moving at the speed of light, then the light that's shining from his face is moving right alongside of him, and he never catches up to the mirror because it's always ahead. So it's just a blank mirror. He doesn't see anything. And so Einstein was bothered by that. He wanted to see something. He wanted to see his punum. He wanted to see his face in that mirror. So he began to wonder what it is about physics that would allow one to think about such things as what happens when you're moving at the speed of light. And it turns out that in order to do that, in order to understand that, he had to make a singular postulate. It was considered at that time, and it probably for all time, to be the most amazing singular postulate pulled out of the blue, other than Dirac, who we may talk about a little later.
Dirac later, yes.
That Einstein's point of view was instrumentally magical, and it was totally out of the blue. And that is that there is no speed that is greater than the speed of light. He didn't quite say it that way, but what he said is that regardless of what speed you're moving at, the speed of light, as far as you are concerned, will always be the same speed, regardless of whether you're approaching a source of light or moving away from a source of light. That may seem, well, okay, I understand, but it
totally defies conventional Newtonian physics.
It does, because let's say you're in an airplane and you're flying towards a city or something like that, and the airplane is moving at a certain speed, and
500 miles an hour.
Let's say 100 miles an hour, and somebody down below is watching you as you're walking down the aisle of the airplane. And if he forgets there's an airplane flying and just watches you, and you're moving at, say, 1 mile an hour, and the airplane's going at 100 miles an hour, he just watches you would be having a speed of 101 miles per hour.
Right.
So that makes sense. But when it comes to the speed of light, if that was not a human being going from one end of the airplane to the other, but a particle of light, a photon moving at the speed of light, then the person on the airplane would measure the speed to be the speed of light, but so would the person on the ground. He would see the light being moving at the same speed, regardless of the fact that the airplane is moving at 100 miles an hour. He wouldn't see the speed of light from his perspective as the speed of light plus 100 miles per hour.
Yeah.
He would only see it the same number that you measure, and that drives you crazy. How can that be? How can it be that there's two contradictory stories being told here? And the answer is, when you come to light, space and time begin to change their whole texture. They become intertwangled, they become intermixed, so to speak, and what is space for one can be time for another, vice versa, and space-time then becomes an emerging concept. And this is what Einstein's basic idea led to.
And if you were riding on a photon at the speed of light and you had a watch on, the watch wouldn't move at all, would it?
Well, that's the next thing which arises from this. As we said, space and time change. And so what happens is that when you compare the time it takes for a particle of light to go from one end to another end of, say, on the rocket ship or on the space on the airplane, you could time that, and you would say, okay, it went let's say 10 feet in roughly 10 nanoseconds, because light travels at the speed, as we would measure it, as about 1 foot per billionth of a second. 1 foot per nanosecond, roughly speaking. So then you would say, okay, well then, if you were riding on that photon and you had a clock, you would show your clock elapsing exactly. Well, you flew 10 feet, well, you must have gone 10 nanoseconds. But that isn't what happens. As you start approaching the speed of light from, say, zero speed, and you keep moving faster and faster and faster, your clocks get out of kilter with clocks that are not moving. And they begin to apparently slow down. Now, slowing down doesn't mean they start they don't like slow down like a slow moving going like that. As far as a person who's moving at that speed, everything seems normal. But when he compares how long it took him to get from A to B as to what you would say how long it took to get from A to B, his time would be shorter.
And this has been confirmed experimentally.
Many times in many different ways. I was working at the University of Illinois during a time when a film was made by one of my professors who actually showed that moving mesons actually live longer in flight than they do on their natural in their natural way, because they would spend in their natural time, they'd spend only like a couple of microseconds of their time. To us, it would appear longer. So time shortens as you speed.
Right.
Now, as you speed up towards the speed of light, time gets so short that it goes to zero. Not only that, but the distance you're traveling in the direction you're traveling, that distance shortens as well. So not only are you traveling a shorter period of time, you're also traveling a shorter distance, and when you reach the speed of light, distance goes to zero, time goes to zero, ergo, there is no space. There is no time for a particle of light. So light doesn't experience space and time.
If I was a photon, I would be everywhere at once and every time at once.
Not only that, your birth and your death would be the same.
Well, now that seems to say something about consciousness, especially because we use the metaphor of light very often to refer to consciousness.
Yes, we do, and it's an interesting highlight which may evolve from this is that the fact that there is no space-time tells us that there is something that emerges from that which is not space and time to something which is space and time. That which is not space and time, in essence, is light itself. That light itself, although it appears in space and time and is measurable by those of us who are not moving at the speed of light, it in essence itself is not in space and time because it doesn't experience space or time. So if it doesn't experience space and time, those things don't exist for it.
I understand, by way of example, that it takes about 8 minutes for a photon to travel from the sun to the Earth.
That's right. But for that photon, no time had passed between the sun and the Earth.
Or distance. Everything is like all at once.
It's all in one little point.
The whole universe.
The whole universe, everything.